Hello, Mr. Lopriato here. This is a video for AP Chemistry. Again, it's on the basics of bonding, and in this video, we are looking exclusively at formal charge. So formal charge is a tool we have to analyze a Lewis dot diagram, a Lewis structure. All right, so the way we calculate the formal charge, and we can do it for any individual atom, is we look at the number of valence electrons that a free atom or an individual atom should have, right? And then we subtract the total number of non-bonding electrons, those are the lone pairs, and we subtract the total number of bonding electrons divided by 2. All right, those are the chemical bonds, and we divide by 2 because we want to remember in the chemical bond, the individual atom is only contributing 1 of the electrons that is being shared. There's 2 electrons total in the bond, 1 coming from each atom. All right, so here we're looking at carbon dioxide. This is a Lewis structure that we should feel comfortable with. We have the 2 double bonds, carbon in the middle, the oxygens on both sides. All right, so if we think about the left oxygen, oxygen should have 6 valence electrons. It's group 16 element, 6 dots. That's easy. All right, so when we look at it, 4 of those electrons are non-bonding. Those are lone pairs, 2 lone pairs, and there are 2 chemical bonds. Now, each bond includes 2 electrons, but the individual oxygen atom is only contributing 1 electron per each bond. So we can see in purple, the 6 electrons of oxygen are around that atom, and it's sharing 2 electrons with carbon. So when we think of the formal charge, it should have 6. It is being represented with 6, 4 from the lone pairs, 2 from the bonds. And remember, this is 4 electrons total, but it's being divided in half to give us 2. So 4 plus 2, 6. 6 minus 6, 0. The oxygen has a formal charge of 0. All right, now the carbon. Carbon should have 4 valence electrons. All right, when we look at this picture, it has 4 bonds. Now remember, each bond is 2 electrons. That gets us to that total of 8 electrons and how carbon satisfies the octet rule. But it only has 4 of its own electrons that it's contributing, right? If we divide the total number of bonding electrons, 8, divided by 2, we get 4. So when we compare carbon's formal charge, it should have 4, and it's using 4. So 4 minus 4, 0. A formal charge of 0. That is good. All right, and the oxygen on the right, it's going to have the same thing. It should have 6 electrons. We can see those 6 electrons. 6 minus 6, 0. All right, now how about something like XeF4? This is kind of a funky Lewis dot diagram. We might not be as comfortable with this molecule. It's weird. We have xenon. It's a noble gas. It's bonded because it's bonded with fluorine, which is a highly electronegative atom. And it's an expanded octet. So let's look at fluorine. Fluorine should have 7 valence electrons. We should be able to tell in this structure all 4 of the fluorines are identical. All right, so fluorine has 7 valence electrons. Well, how many does it have in this structure? Well, it has 3 lone pairs. So that adds up to a total of 6 valence electrons. All right, so 7 minus 6 is going to leave us with 1. And it has 1 bond. Now that bond represents 2 electrons, 1 coming from the xenon and 1 coming from the fluorine. So that's why we take the number of electrons in the bond 2, divide it by 2, that gives us the 1, right? We can see it only has 1 electron that is going into that bond. So 7 minus 6 minus 1 gives us 0. Fluorine has a formal charge of 0. The xenon. Xenon should have 8 valence electrons. All right, when we look at this diagram, we see 4 valence electrons in the form of lone pairs. All right, and we see 4 more valence electrons, each coming from half of the total number of electrons in each bond. All right, so 8 minus 4 gives us a formal charge of 0. We generally like formal charges of 0. All right, now let's look at a polyatomic ion. We have something like the cyanate ion, CNO. All right, let's say we drew this structure. We followed the rules from our Lewis dot structure video. All right, we tried this out. Well, now formal charge allows us to analyze the structure we drew. It helps us to determine if we did a good job or not. So let's start with the middle. The nitrogen should have 5 valence electrons. It has 4 bonds around it. That contributes 8 electrons. We have to divide it in half. So 5 minus 4, the nitrogen has a formal charge of +1. It's kind of like the nitrogen has lost an electron. All right, it is not an ion, but it has a formal charge of +1. All right, now if we look at the oxygen on the left, oxygen should have 6 valence electrons. All right, based on this picture, we see 2 valence electrons in the lone pair, and we see 3 more in the 3 separate bonds. So 6 minus 5 for the oxygen gives us a formal charge of +1. All right, so again, it's kind of like the oxygen atom has lost an electron, right? It's somewhere else in the molecule. And then when we look at carbon, well, carbon should have 4 valence electrons. In this picture, in this drawing, it has 3 lone pairs. That's 6 electrons alone, plus 1 from the bond. So 4 minus 7 gives us a formal charge of -3. It's like this carbon atom is holding on to 3 extra electrons that it shouldn't have. So this kind of shows us we have a bad Lewis diagram in front of us here. We do not like these extreme formal charges. The other thing I want to point out, the total of the formal charges will equal the charge of the polyatomic ion. +1 plus +1 minus 3 gives us -1. In our previous examples, it was neutral molecules, and all of the formal charges added up consistently to 0. All right, so instead, what should happen is when we go to draw CNO, the carbon should be in the middle, right? In the previous example, we had nitrogen in the middle. That didn't work out. Carbon should be in the middle. It is less electronegative, right? And there's 3 different ways we could draw it. We could have a double bond between the carbon oxygen and the carbon nitrogen. We could have a single bond to the oxygen and a triple bond to the nitrogen, or we could have a triple bond to the oxygen and a single bond to the nitrogen, okay? Couple of different ways. All of these, in theory, would be valid based on how we learned how to draw Lewis structures. But now we have this skill or this tool of formal charge to compare them, right? So if we look at the carbon in this upper left molecule, all right, it should have 4 electrons. It is shown with 4 electrons, right? 1 electron each from those bonds. So carbon has a formal charge of 0. Nice. The oxygen should have 6 electrons. It is shown with 6 electrons. That is good. And now nitrogen. Nitrogen has 5. In this picture, 2 lone pairs gets us to 4, 5, 6. All right, so nitrogen has a formal charge of -1. So 0, 0, -1. All right, those are simpler numbers. We like that. We like seeing the formal charges of 0. In our second drawing, carbon has a formal charge of 0 again. Has 4 bonds. That would be 4 electrons, 4 minus 4, right? Carbon should have 4. It is using 4. The oxygen has a formal charge of +1, right? Oxygen should have 6 electrons. In this depiction, it only has 5. So 6 minus 5 plus 1. Nitrogen should have 5. In this picture, it has 7 around it. So that's giving it a -2. So +1, 0, and -2 adds up to -1, but we like the first one better because we like having more atoms with a formal charge of 0, right? We don't want to get too far away from 0 in our formal charge. All right, my bottom drawing, the carbon has a formal charge of 0. All right, 4 bonds, that's 8 bonding electrons, but we divide it in half, right? Because carbon's only contributing 4 of its own electrons, so formal charge of 0. The oxygen should have 6 valence electrons, but it is shown with 7. 6 in the lone pairs and 1 in the bond. So 6 minus 7, -1. The nitrogen should have 5 valence electrons, and it is shown with 5. So it gives us a 0. All right, so right off the bat, the tool of formal charge helps us to see that this drawing over here, the O triple bond C single bond N, is clearly the worst possible Lewis structure based on the 3 we're looking at. And it's actually going to be the oxygen single bonding to carbon and then triple bonding to nitrogen as the most plausible Lewis structure. The reason for that is oxygen is the most electronegative of the three elements. So if one of these elements were to pull in an electron around it, it would be the most electronegative, and that's why it has the formal charge of -1, while the other two elements have formal charges of 0. All right, so formal charge is a skill we have. It is a tool that allows us to compare existing Lewis structures or to help us feel confident in the Lewis structures we draw.